Okay, today's lesson we're working on comparing linear with exponential. Linear is all the work that we did in the fall, so all the slope work, and then exponential is all the equations and work we've been doing since we've been back, so since January. Just a reminder, our linear models will use slope-intercept. So it uses y equals mx plus b. The m stands for the slope, or the rate of change, and the b is the y-intercept. If you notice, a question asks about a fixed dollar increase or something where it's increasing or decreasing at a constant rate of change. You're leaving. If it talks anything about a fixed dollar increase, so for example, if you get a, let's say, dollar raise per month, that's going up at a fixed rate. That would be a linear equation or a linear model. So if it's going up or down by the same amount every month. And that I have drilled into your head over the last 3 or 4 months. And then what we've been working on now is exponential. Exponential uses the equation y equals a times b to the x power, a being the y-intercept, and b is the growth or decay. Exponential is when there is a fixed percentage increase. So anytime you're talking about percentages, you're going to see an exponential model used. For example, if you get a 2% raise each month, okay, we're going to be comparing 2 different jobs. So example 1, letter A. You have 2 job offers. Job A, the first job, offers you $1,000 for the first month, plus a raise of $100 each month. Tony, will you do me a favor? Will you shut the door for me? Thank you. Job A, you get $1,000 to start, and then each month you'll get $100 more for your raise. Job B is $1,000, but job B is going to get a raise of 10% each month. Okay, I'm going to make a table to compare. So it's going to be the month, job A, how much job A makes, and then how much job B makes. We'll do it 0 months, 1, 2, 3. I'm going to run out room. I want to go up to 5 months. And we're going to come up with the equation for both of these, so then we can just put them into our calculators and come up with the table. Okay, let's do job A first. Job A is $100 per month, so job A is going to be linear. So job A is going to use y equals mx plus b. So the equation for job A will be y equals, slope is how much the raise is, or how much it's changing per something. So it's changing $100 per month, so 100 is your slope. So put in 100 for the slope. Then we put the x. The b value is your y-intercept, or your starting point. The job started at $1,000, so plus 1,000. So there's job A's equation. We're going to need that in a minute to put that into our calculator. Okay, then we'll do job B. Job B has a 10% per month raise. So that percentage means it's going to be exponential. Exponential equations use y equals a times b to the x power. So job B will be y equals, A stands for the starting point, and this job starts at $1,000. B is that growth or decay. So it's growing, so it's 1 plus. It's going up 10%, so that's 0.1. So first you have to make that percentage into a decimal, so that's 0.1, and it's 1 plus the r. So 1 plus r, so 1 plus 0.1 is going to be 1.1, and then it's to the x power. Okay, get your calculators. We're going to put both of those equations in. We're going to pull up the table and fill this in for 0 through 5. So I got the 1.1. If you're not sure where I got the 1.1, the growth rate is always 1 plus whatever that percentage is as a decimal. 0.1 is 10%. 10% is 0.1. 1 plus 0.1 is where I'm getting this 1.1. Okay, go into your graphing calculator. Okay, so go into your table and you're putting in both of those equations. So I'm going to put in the linear one, 100x plus 1,000. And then the exponential one, 1,000 times 1.1 raised up to the x power. So you'll put in both equations and then go to your table function. So we're going to fill out your table then for how much you're getting paid for job A for 5 months and job B for 5 months. So just fill that in on your piece of paper. If you're using Desmos, remember you just go to the right and you can put both of them into your table. Okay, so you have your table of values. Eventually, anytime you have an exponential function, it will always be bigger eventually than a linear function, because exponential is always getting bigger eventually. So anytime you're given an option, always go for the exponential model if you're going over time. Usually the first few months, yeah, the linear might be more, but eventually exponential will always exceed a linear model. So a lot of times the questions will say, like, at what month are you going to make more, or things like that. So you can see that they're making the starting pay is the same. Month 1, they're the same. But already in month 2, job B is making more. And then in month 5, more. And then if you even looked at the table, if you go to your X's and you keep going down, you'll see it eventually it's making way more money. So the longer you stay at that job, you're going to be making a ton more money than if you stayed with that linear equation. Okay, let's do another question like that. So again, if there's a flat rate raise, that's linear. If it's a percentage, it'll be exponential. Okay, this is another question where we have 2 salaries. Job A, you get paid $1,000 for that first month, and then you get $200 a $200 raise each month. Job B is going to start you at $1,000, but then they have a 15% raise each month. These are both raises. Both of them are starting at $1,000. Job A is going to give you a $200 raise each month. Job B will give you a 15% raise each month. I want to know at how many months, when will job B give you more money? So first I want you to come up with the equation for both of the jobs. So job A, it has a flat rate of $200 each month. So if it's a flat rate, it's going to be a linear model. So when you come up with the equation, it should be in mx plus b. Come up with the equation then for job A. Y equals 200x plus 1,000. Because you're getting $200 each month and you started at 1,000. Okay, then come up with the equation for job B. Job B has a percentage increase, so then I know that's exponential. So when I come up with that equation, it'll be y equals a times b to the x power. Come up with that equation, please. 1,000 times 1.15 to the x power. Because remember, it's a 15% increase. So 15% as a decimal. 1 plus the rate goes in the parentheses. So it's 1 plus 0.15. That's where I'm getting the 1.15. Okay, put both of those into your graphical calculator and figure out when does job B pay more. Okay, so if you put those 2 in and then you go and look at, not the graph, the table. Oops. Okay, at 0 months are both making the same. Month 1, the first equation's more. It's at month 5. At month 5, you're making $2,000 with the first job, but in the second job, $2,011. So at month 5 was the correct answer. Okay, you're going to do the next question with your table. This one's a little bit different, but I think you guys can figure it out. Okay, would you rather? Okay, I want to know, would you rather have $1 million or a penny that doubles Bless you. Every day for 30 days. Okay, with your groups, decide. Would you rather have $1 million or a penny that doubles every day for 30 days? Okay, so the equation, we're doubling, so that's exponential. Y equals, the original value of a penny is 1 cent. It's doubling, so you put a 2 as the growth factor. To the x power, but I'm asking about 30 days. So put that into your calculator. And it's worth that much money. One, two, three, come on. It's worth $10 million. So clearly the penny will be worth more. Okay, example 2 now is going to deal with word problems. And the word problems are going to be asking if it's linear or if it's exponential first. So for example 2, keep in mind if it is a linear model, it'll say something about a constant rate of change. Or slope. It'll be talking about something adding or subtracting. If you're adding or subtracting each month, each year, whatever, that's going to be a linear model. Then we'll use slope-intercept form for those types of questions. So if the question has wording in it that talks about a constant rate of change, or if it uses the word slope, if you see anything about it adding or subtracting, that's probably your clue that it's going to be a linear model. Not quadratic, exponential. We'll talk about a constant percentage. A constant percentage of change. So usually your clue is if you see a percentage, it's probably exponential. A constant percentage of change, and that is by the multiplying or dividing. So a percentage of change is when it's multiplying or dividing. So any of those questions about, like the zombie question, the zombie kept biting 3 more people, so it's multiplying by 3 each time. That's going to be exponential. If you see something's depreciating at a percentage each year, it's going down, it's going down, it's really dividing or multiplying by a number less than 1. So if you see any of that type of wording, those are your clues on if you're going to be making a linear equation versus an exponential equation. Okay, so here's the first word problem. This is 2A. You join a fitness center that charges a membership initial joining fee of $50. Okay, so you're joining the gym. The initial fee is $50. Okay, so you join a fitness center that charges a membership initial joining fee of $50. Then it costs $24 a month to use the gym. So then you have to also pay $24 per month for the gym fees. So just to join, $50, and then you also pay $24 to go to the gym each month. Okay, the first question is going to ask, is this linear or exponential? So if you're paying the same amount each month, it's going up at a constant rate, so that $24 per month is making this linear. It has a constant rate of change. It's going up $24 each month. Then I want to know if it's increasing or decreasing. And I have a lot of people, I thought this would be something easy, but I've noticed when you guys have word problems, some of you guys are missing, like the word problems where it said depreciation, I had a lot of people that aren't understanding that that's decreasing. So I want to know, is it going up each month or down each month? So if you're paying another $24 each month, that's increasing. You're paying another. So you're adding each month another $24 to that bill that you've had to pay over the year. And then I want to know what's the equation. So since I said it's linear, I know the equation will be set up in slope-intercept form. So for this situation, it'll be y equals, m stands for the slope, so how much it's changing per month, so that's the 24. Then we always put an x. And then what was the initial starting fee? That was the $50, so plus $50. And that's it. Okay, 2B. Okay, this word problem says, you bought a new laptop this year for $800. Okay, so you have a laptop that's $800. Okay, you bought a new laptop this year for $800. The value of the computer will depreciate at the rate of 29% each year. So it's going to depreciate 29% per year. Okay, first I want to know if it's linear or exponential. Your cue is, if you see percentage, it's probably going to be exponential. Then I want to know if it's increasing or decreasing. The word depreciate means it's going down in value. So you guys understand, like a lot of your, if you buy something used, it's worth less money because it goes down in value because either it has wear and tear on it or a better product has come out that's more advanced. So this laptop is going down 29% each year. So it is decreasing. Then I want to know the equation. And this is where I see a lot of people are struggling. So for this exponential, the equation will look like y equals a times b to the x power. So when I write it, it's going to be y equals, A stands for the initial value. So the laptop started at $800. Okay, it's decreasing. It's going down per year. So this is going to be the decay model. So your B value is going to be 1 minus the rate. The rate is 29%, so that's going to be 1 minus 0.29, because 29% is 0.29. So in your calculator, do 1 minus 0.29, and you get that's 0.71. So that's what's going in the parentheses. And then it's raised to the x power. So your B value is 0.71. And I got that number by doing 1 take away 29%. So 1 take away 0.29. Okay, the rest of these questions, I'm going to put a sentence, and you're going to figure out, is it linear or is it exponential? Okay, question 1. Enrollment at a school is initially 446 students, and it's growing 8% each year. Okay, talk with your table. What kind of model will that be, exponential or linear? Okay, everybody, what's that one? That's exponential because it's growing by 8%. Okay, the next one. A salesperson initially earns $50,431 per year, and then they receive a yearly salary raise of $725. Okay, talk with your group. Okay, everybody, what kind of model is that? That's linear because it's going up at just a flat rate, $725 each year. Okay, next one. A customer borrows $441 at 7% interest compounded annually. Okay, everybody, what's that one? Exponential because it has a percentage. A wildlife park has 28 zebras, and then it sends one zebra to another wildlife park each year. Okay, what's that one? That is linear. It's losing one zebra per year. The value of a house is $546,792, and then it decreased by 2% each year. Okay, what's that, everybody? Exponential. And then finally, a population of a town is 99,999 people, and then it decreases by 190 people each year. Figure out that one? Okay, what's that one, everybody? That is linear. Okay, tomorrow we'll do the activity that goes with this. So you have time, you have what, at least 15 minutes. Some of you owe me lots of work. That is your time to get caught up. If you've been absent, I have not put into the grade book the work that you guys did yesterday, those 2 worksheets from yesterday. So if you know you didn't finish those 2 worksheets, you need to work on those. You can move around and work with other people. If you are caught up on everything, then you can go on your phone.